All right, ladies and gentlemen, we're back now. For those who are interested, there are still plenty of slots available, and apparently a Star Wars episode going on. There's still plenty of slots available for lightning talks this afternoon. So if you are interested in a lightning talk, come see me put something in my little collection of lightning talk things here. Our next speaker is another Django core dev. This is Josh Smeaton, who's here to talk about customizing your SQL inside the Django ORM. Thank you very much, Josh.
Thank you. Can you hear me? Is that fine? Yep. Hi, I'm Josh. I work on the ORM, on the Django ORM. I play with SQL quite a lot. You can find me on the web under Joshua, Django IRC, Twitter, GitHub, the Slack channel, etc. I work for a company called Engage. We do call center apps, reporting, a lot of reporting, which means a lot of SQL, which kind of bleeds into the next point. I'm a bit of a SQL nerd. I've kind of got a love-hate relationship with it. I have a lot of customers asking me how their reports work, and I try not to tell them I don't know too often, so I have to dig into a lot of those. I'm the primary author of Expressions, which is a new feature to Django as of 1.8, so it's, what, a year and a half old now, or 2 years old, something like that. And after that was committed, I was invited onto the core team for that. Okay, so some recent developments in Django that help users go a bit of a way to being able to really get in there and alter the SQL that Django generates. Starts off with 1.7. So there were a couple of patches landed for 1.7 that kind of got us to a reasonable point for users. And the main one was lookups. So here the lookup, is that a pointer? Yes. So the lookup here is the contains method. So pre 1.7, you were at the mercy of what Django offered you. So it was greater than, equals, less than, is null, that kind of thing. But there was no way to write your own. So if you had custom fields that required custom lookups, say you were working with arrays in Postgres or HStore, etc., there was no way to actually write your own lookups. So that changed in 1.7. So filters are where clauses. So lookups are for generating conditions in a where clause. So you have the left side, which is the field you're querying, the contains, which is the operator that sits in between, and then the right side, which is the data that you're passing between. Transforms are very similar. You might confuse this here because it's just underscore lookup. So here it's actually the lower portion right there. That is a function. So the left-hand side, you've got your field name. If you apply lower to it, it'll use a SQL function to lower that, that name, and then you can apply an operator, so a lookup contains there. So this will find any products where the name contains the word jumper. Lowercase, uppercase, mixed case, it doesn't really matter. Okay, so expressions. So 1.8, we got expressions, and this is the feature that I'm mostly responsible for. There were some helpers along the way, so that was good. But this allowed you to really get in there and annotate ORM queries with new data. So add select fields. You could do complex aggregation, so you could add two fields together. You could add two aggregations together. Before that, you could only ever aggregate on one field. So what this query does is it's a sales by month query. So it'll take a sale date, it'll truncate it down to the first of the month. So all of the data within that month becomes one field, it groups by that one field. Then you take a count and there's your sales per month query. All right, so sales reporting. A lot of queries come down to variations of sales reporting, especially when you're doing, well, any kind of reporting, when you're doing aggregation, that kind of thing. So I've written up a little store. So it's a clothing store called Clothe Me. There's two models. There's a sale model, there's a product model. So let's step through this. Okay, so this is an IPython or Jupyter notebook. So it's got, the code actually runs, and this is real code here. So this is our basic query. So we take a sale, we group it by product category, we then annotate the sales and the revenue, and we get revenue and sales per product. That's fairly simple stuff. This was always possible. But then your boss comes in and they say, we don't care about clothing for kids. Like, that's not our target market. get rid of it. And you go, okay, boss, anything for you. And you write an excludes filter. So to exclude, you use exclude instead of filter. You filter out the kids category, and then you do the grouping as you did before. But then your DBA and your ops person, they come over and they say, this query sucks. This query is no good. And that's a query that Django actually generates for it. And you can see that there's a not. It doesn't use a not equals like you normally would for a SQL. Who writes SQL here? Who's aware of SQL? Good, because a lot of the time you hear a lot about people using ORMs and not understanding the SQL beneath, so it's good that people have a good understanding. Okay, so traditionally here for this kind of report, you'd put a not equals there and you wouldn't put a not at the front. But Django doesn't do that. Now, this version of the query uses 5 extra characters, which is why your ops people are blowing up. Right, matters, web scale. And Django actually has a lot more work to do for negated queries as well, because it's got to take in subqueries into consideration. It's got to do a whole lot more processing. So with lookups now, we can write our own. And my phone's died. It's all good. We can write our own. So we can decide, right, Django, we don't like how you do your not exclude. We're going to write our own. So right here, we're doing a not equals. We're providing a lookup name of NE, so that's the underscore underscore NE or underscore underscore contains. That's the lookup name. And that's the meat of a lookup, of a transform as well. So the main method is an as-SQL method. And what that does is it takes the left-hand side, compiles it down to SQL, which is what the process LHS is. It takes the right side, which is your value that you're comparing it to. It compiles that down to SQL. It then uses string interpolation, which is generally bad, but we're hoping that users are not providing data here, but that's why we've also got the params on the end to account for SQL injection. And then we return the SQL that the query needs to run. And I've timed it. You save 30 microseconds by writing a query that way, so your ops people are happy. Okay, so Milton, lovely old Milton. He doesn't like categories. He doesn't care about products. He just wants to see revenue by quarter because he's got quarterly reports to write. Quarterly, well, investors care about this kind of stuff too, I guess. So Django doesn't have the concept of truncating to a quarter. So as of Django 1.10, you've got a whole lot of date-based lookups. So you've got extract queries, which will let you pull out a year or a month or a day. But you've also got truncation queries that will let you aggregate the dates. So you can reduce it, you can get rid of the time, reduce it down to a date. You can get rid of the day, reduce it to a month or a year. So they're the ones that are built in by standard. But Milton wants quarterlies. So we write our own function to do this. So transforms are function-based expressions, but they also come with a lookup name parameter, so you can also use it in a filter clause. That's not terribly relevant here. We'll just call this a function. So what this does, it takes a function name, which is date trunc in Postgres. We're writing this for Postgres because we don't use MS SQL. Yeah. We provide a template parameter. Usually you don't need to change this, but because we want to hard code the quarter parameter in, we're changing that as well. We're giving it a lookup name. So, okay, we've got an init method that takes a single expression. Expressions, functions, transforms, they all work together. So you can combine, you can merge, you can add, subtract them all together. So everything takes an expression, everything operates on expressions. It's a big tree of expression objects. So we set the output field to date time, and that just means that whatever is coming back from the database is going to be loaded into a date time field. So then it can do conversions, so then you can do lookups on it. So everything kind of plays nice together. Django understands model fields, right? Okay, so we've got a couple more methods here. These aren't strictly necessary, but there's a lot of methods that you can override to provide more functionality depending on what you want to do. So here we've got a basic convert method. And what that does is it checks to see if we were expecting a date. And if we've got a date time coming back from the database, it just truncates the time away and returns a date for you. As well, we've got a as-SQL-lite method. There's expressions use an expressions API, so it's a set of about 6 or 7 different methods and properties. And one of the cool things about this is that different backends, you can provide support for different backends directly in the front-end objects. So that was never possible before. If you wanted to build your own expression or lookup, what you had to do was build the front-end object like this. You also needed to add all of the SQL into the backend that you wanted to support. So if you wanted to support something like MongoDB, you'd have 2 places to add your expressions. Or if you wanted to support MS SQL, 2 places to put your expressions and your SQL. So here, because SQLite doesn't support truncating to quarter, we boot it off. We give them a nice error message so they don't see the database error message. Now that's kind of a lot to take in. Resolve expression is one of the main parts of the query API. And basically what it does is it gives you access to the query that you're adding it to and lets you do any pre-processing that you might need to do. Now the main thing to remember about resolve expression is that you need to do everything on a copy of the object. So if you call the superclass, it'll return a copy for you, and that's so you're not mutating objects that are being used across multiple query sets. So all this does is provides some helpful error messages again. If the input's coming through isn't a date or date time field, get rid of it. Same thing for the output field, and then it just returns a copy. Okay, so we wrote a whole lot of code just to support quarterly aggregation, right? So you jump onto IRC because you need to support time zones. You don't know how to support time zones, so you're going there for a bit of help. And Funky Bob tells you to read the docs because in 1.10, you've got a whole lot more. So now that trunk base is in 1.10, and like I said, all the truncation and extraction functions that we spoke about before, your code reduces a lot. So all you have to do is override the kind class property, give it a lookup name if you want to support transforms, and then you're good to go. So this query down here, we're still doing the same thing. We're excluding kids, and we're aggregating to a quarterly, and we're using the lookup quarter here, and we get a count of 506. Okay, so here's the actual report that Milton asked for. We're doing the same thing, restricting by kids. We're annotating on the quarterly, so we're adding the quarter function as a select attribute. So then we can restrict it and group it by using values call later on. So what we'd like to eventually support is just throwing sale date underscore underscore quarter into the values call and completely avoid the need to annotate that on as well. That'd be a great thing to support if you're looking for something to do at the sprints, and there's plenty of Django developers to kind of help you do that too. So we group by the quarter, we take the revenue, we take the sales, we order it by quarter, and Milton's got his nice little report. All right, so bosses are happy, but now they want more. I think they're just kind of frustrated at the moment with how good you are. So now they want to break out revenue into their biggest markets. So Victoria, New South Wales and Australia, they say that's where all our customers are. Show us those individually so we can start targeting customers there. So for this, we'll need a conditional expression. So we need to pivot data, essentially. So we could create a row that said Victoria, quarter, blah, 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 but that'll get unwieldy the more columns that you add into the grouping. So what you want to do is you want to extract the data out and put it into a new column, which is what sum and case do. So you want to take the aggregate of a condition. So when the state equals Victoria, you want to get the sale price. And when it's not, then you just want to say, empty, and then sum it all together. Now, if anyone's familiar with Excel, and I'm sure many people are, that sounds like SUMIF. So there's a SUMIF function in Excel which takes a condition, it takes the field that you want to sum up, and add it all together. So instead of writing that big wieldy case when expression with a sum, we'll write a big function instead. And that'll approximate. Well, it'll do the same thing. Like I said before, all expressions are just a big object tree. So you can combine them in interesting ways. You can rename them. You can do exactly what we're doing here, which is copying the signature of the case when structure, build it all up together, and then we can use that instead of a big long case when string in our query sets. Okay, so let's put that all together. All right, here's our final query. And it's getting pretty big and a little bit hard to read on this screen. But we do the same thing we did before. We're excluding kids from the calculation because that's not what we're interested in. We're adding the quarterly date, or we're aggregating up to a quarterly date. We're then grouping by that quarter. We're taking the revenue of the sale, sum of the sale price to generate revenue. We're taking the count of sales to get the number of sales. We're calculating the revenue of Victoria, we're calculating the revenue of New South Wales, and we're ordering it by quarter. So that's looking pretty good. But boss doesn't like it. He's over it. He changes his mind all the time because he's not a very nice guy. And what he wants is a growth report instead. He hears about all these SaaS companies doing month-over-month growth. And he wants to be difficult. He knows month-over-month is supported by Django, but he wants to be difficult. He wants quarter-over-quarter growth instead. He goes, that should be easy. You've done this up until now. So this is the SQL that would get us there. Let's go back a minute. Quarter-over-quarter growth would be easy if we could compare the difference between revenue from one quarter to the next. So if you could write some SQL that was able to investigate the row or see the row behind it, then we could calculate that quite easily. But standard SQL doesn't, or that's debatable. Standard SQL doesn't really have a mechanism for doing that. Some of the newer standards do though, and they're called analytical functions. Postgres supports them, MS SQL Server supports them, Oracle supports them. MySQL doesn't support them. Huh. Cheap laughs, MySQL bagging, sorry. Okay, so if we're writing this query out, this is probably what we'd write. So we've got our original query, truncated a little bit for space, over here. So we'd write our normal date trunk, we'd group by it, we'd calculate the revenue, we'd do all our grouping, etc. Easy, that'll give us the table that we had before. But now we need to calculate growth and the revenue that happened the quarter before and use those together, and that's what the lag function does. So what lag does is it lets you see a row before based on some ordering. So we're ordering by quarter. Lag by default looks at the row one before. So if you take revenue of your current row, divide it by the revenue of the row before, and then do your percentage calculations, you get a nice little growth. So we've got the SQL to do that, but how do we get Django to execute this? The ORM doesn't support analytical queries. The ORM doesn't really support subqueries well. It doesn't let you mess around that much with it. So our options are limited. But Django does give you the database connection directly, and you're able to get the cursor out of that directly. So you might have heard about raw queries, Django.raw, objects.raw. You might have heard about objects.extra, but those aren't actually going to do anything for you in this case. So what we do, we grab the SQL from before, we take a cursor, we execute it, we get all the column names so we can zip it up together and form a nice little table. We execute the query and we've got our results directly into Django. So we just skipped all the ORM altogether, but that's fine. That's fine. Because the ORM is just a convenience. It's supposed to make the easy things easy, the standard things easy, and Django wasn't really built with reporting in mind, right? It was built for CMSs, it was built for, categories and shops and one-time passwords. It didn't really have these big analytical queries in mind. But as long as you are targeting a specific database, which most people are. Most people don't run these kinds of queries on multiple database types unless you're writing reusable apps, and then you've got to do what you've got to do. But you can skip the ORM, go directly to the database, save yourself some time, save the ORM from doing a whole lot of work, and get the job done quicker. Your DBAs will be happy too. And that's me.
Oh, okay, once again, up for questions, and I think Marcus wants to ask a question. So
Thanks, Marcus.
Sorry, mate. You said that you can't do the lag functions through the ORM. You can still, so from my experience on the ORM, .annotate can put stuff into the select clause. Mm-hmm. So I can come up with a thing that then boils down to a bit of SQL, which represents. How would you do that?
I've been thinking about how that would be supported for a while. And there's windowing clauses that would be a little bit weird to construct with the ORM, although you could do it because they're all just objects. But then ordering the query set that you're wanting to write an analytical function over and writing the subquery in such a way that the analytical function would work, that's the difficult bit. So you can write some analytical queries without worrying about the rest of the aggregation or teaching the aggregation framework to or what analytical functions were, and then it might be able to support basic ones, but in general, it's not possible just yet.
Most of the time, the ORM gives you quite a good abstraction, and you never have to worry about, you never have to think in SQL terms. Mm-hmm. That works almost all the time. The only time I've noticed it sort of leaking through to expose SQL is when you are selecting some object and filtering on the reverse end of a foreign key, and then you have to use distinct to sort of throw away the objects, you know,
right,
to make them distinct. And if you accidentally or somehow or other are ordering on something that's also in the reverse end of the foreign key, even distinct doesn't work because suddenly they're all out of order. And so you kind of have to know that SQL is there under that circumstance and probably not many other circumstances. Mm-hmm. Does that worry anybody else?
Yes.
Oh, good.
Because you don't get any error messages either. You just get incorrect results.
You kind of have to, the abstraction breaks in that
It does.
case.
It totally breaks down. And there's ideas of how to fix that. Well, the problem itself is the ORM doesn't know whether it should reuse a subquery or not. And that's kind of what the not equals filter was all about. People have been asking about that for years because of that issue that you just mentioned. When you're doing excludes across many-to-manys, or when you're doing reverse filters, it's essentially the same problem.
Yeah.
So yes, it worries people. It worries us in particular. It'd be much better if it blew up and just said, write your own SQL for this particular case rather than handing back incorrect results.
Yeah, I think I agree.
Yeah.
And thank you for the expressions things. It's really useful.
Awesome. Thank you.
Thank you for a very enlightening talk. Python has a philosophy of batteries included. Mm-hmm. How many of these extra queries like the quarterly truncation, for example, do you think will end up in Django core?
Hopefully a lot. Not too many. I know that goes a bit against it. Well, we don't want a whole lot of functions that only work on one particular database or only work on like a small subset of them. That's why the Postgres contrib.postgres module was really good, because they could throw a whole lot of functions in there for all the new field types and stuff without polluting the rest of the namespace. Things that people are going to use fairly often, I think, should make it in there. A whole lot of string-based functions are in there. Date processing, which is really, really common, especially in reporting type scenarios. That's just made it in there in an easier to use form. It was hidden before, but it was still accessible. There's scope for, well, there's more room for a bigger scope, provided that, you know, people want to commit it. If they want to write it and ask for it to be added, that's awesome, and it's a great way to get newbies into development as well, I think. With
the API and having those things in, what support is there for alternate backends? Because I noticed one of the method calls there was called as SQLite. And if you've got an alternate backend that isn't part of Django Core, is there a way of getting those queries translated into your backends?
Yes. So what that does, every connection has, or every backend has a .vendor property. So Postgres is Postgres, SQLite is SQLite. If you had Mongo, it'd be Mongo, MS SQL, MS SQL. So if you define an as vendor, when the expression is being compiled, or the as SQL method is being run, the as SQL method gets skipped, the standard method gets called instead, and that's how we bring, I guess, all these extra features to backends that we might not want to support. Backends can also add their own methods to existing expressions as well with monkey patching. So it's, yes, how else would you do it? Without going in and changing the code, right?
Some sort of registration pattern, perhaps?
Yeah, that's been discussed, but a registration pattern is still going to be a similar thing. It's just going to be a slightly fancier way of doing the same thing with just assigning an as vendor method. It might have been added. I don't think it has. Yeah. Thank you. No worries.
All right, there's no other questions. Thank you very much, Josh.
Awesome. Thank you.